look at how to solve quadratic equations using the square root rule and completing the squared when you have complex solutions. So let me explain what it means when you have a complex solution. So first of all, if you graph a quadratic function, quadratic equation, for example, this one here, we have x squared plus 1. Notice the U-shape, the parabola is not touching, is not crossing the x-axis. So that means there's no x-intercepts. So what that means is we are going to have complex solutions. We do not have the x-intercepts. In other words, we are going to use imaginary numbers. That's where complex solution comes in. Now the big idea of an imaginary number, if you look on this side, is when you have the square root of a negative radicand, negative number inside of the radical, that's when we use I. I stands for imaginary numbers. So just remember the definition of I. Imaginary number is when you have the square root of a negative 1 or negative number. We're going to have to get rid of that negative. Mathematically, you cannot find the square root of a negative number, but if you use I, we can. So I'm going to show you guys first. I'm going to show you first the square root rule, how to solve, and then why do we have complex solution. If you guys don't remember how to use the square root rule, go back to one of my videos. I do have one showing how to use that rule. So the first thing we want to do when you use the square root rule, you want to get the x squared variable alone, okay, by itself. So let's subtract 32 first from both sides. So we have 81 x squared equals negative 32. You want to divide by 81. So this turns into a big 1. We have the x squared equals negative 32 over 81. I notice the number, the bottom number, or the denominator is a perfect square number. So we want to keep any number that's a perfect squared, because remember, square root rule, we are going to use square roots. So if you have a perfect square, keep it. Don't reduce. If you're able to, try not to reduce. Check if you can square root first, find the square root, and maybe that's a little bit easier. So to cancel the square, take the square root of both sides, cancels, x equals, first of all, when we solve, we do need a plus and a minus when we take the square root. Notice that we do have an I here, okay, not an I, a negative. We have a negative radicand. So that's going to tell us, that's telling us we need to use an I. It's inside of the radical. But before we do that, let me use the quotient property to separate the two numbers. So I'm going to take the square root of negative, and I'm going to keep the negative on the top, over the square root of 81. Okay, so I separated the numbers, keep the negative on the top. Then you continue with the number on the bottom. Here's the plus and the minus. Don't forget those signs. The square root of 81, that's 9. On the top, since we have a negative, make sure you use an I. So there's my I outside of the radical. Look at the radicand. If you can simplify, go ahead and do that. So 32, two numbers that multiply to 32, and one of them is a perfect square number. And you always want to use the highest perfect square number that you can find. So you want to simplify using the product property. So x equals plus or minus. Here's the I. The two numbers that multiply to 32. 16 times 2. So notice 16 times 2, that's going to equal 32. 16 is a perfect square number over 9. And you just keep going, simplify. The square root of 16 is 4. So we take 4. Keep the I, square root of 2 over 9. You want to check if you can simplify the numbers outside of the radical. In this case, you cannot. 4 and 9 do not have a common factor. So here are my answers. Remember, we do have two answers. Let me write those down. I'm going to separate them. One of them is a negative 4i square root 2 over 9, comma, and the other one is positive 4i square root 2 over 9. We do have two imaginary solutions, and that's what you have. Every time you have complex solutions, imaginary solutions, you have two. Never one imaginary, is always two. Okay, so the next one is using completing the squared. First of all, to complete the squared, in order to know if you can complete the squared, check that a is 1 and the value of b is even. If b is not even, it's going to be a little bit harder because you're going to get fractions, but when b is even, a is 1, you can use completing the squared if you would like. So it says find the zeros of the function. So first, g of x must go, you have to change that to a 0. So here's a 0. So keep in mind we are using completing the squared. That's what we are doing to solve. We must have the variables by themselves and on the same side. So I'm going to subtract 12 to both sides. This cancels. So negative 12 equals x squared plus 4x. Now you can start completing the squared once you have the x's by themselves. So you find c, which is b divided by 2 and squared. So that's going to equal 2 squared, which equals 4. So this is the number you're going to add to both sides. So there's the negative 12, you bring it down, plus 4, that's the 4 we found over here, and x squared plus 4x plus 4, and there's a 4 we found. Okay, so you add 4 to both sides. You combine, you add, you subtract, so you've simplified. So that's going to be negative 8 on the left side. On the right side, we don't have anything in front of the x, so we don't have to worry about the number, but we must write this down as a binomial squared. So you keep the variable, the number before you square it, that's the number that goes inside of the parentheses, and that's a shortcut, guys. Basically what you're doing with the trinomial, you're factoring, and then you write it as a binomial squared. But you don't really need to factor when you know you have a perfect square trinomial. You just take the number before you square it and you put it inside the parentheses. We are solving, so that means we have to get x by itself. So in this case, we need to cancel the squared. There's nothing outside of the parentheses, so we can cancel the squared, take the square root, cancels. So on the left side, we have x plus 2. On the right side, first of all, I do need the plus and the minus because I'm solving. This negative must go, so we use imaginary numbers, complex numbers. So we put an I outside of the radical and the square root of 8 inside. Check if you can simplify the 8. You can. Find two numbers that multiply to 8, and one of them is a perfect square number. So we have plus or minus I square root of 4 times square root of 2. That's going to give you 8. 4 times 2. And we have x plus 2 over here. You simplify the radical, square root of 4. So plus or minus 2. Keep the I, square root of 2. And we have x plus 2. X is not by itself, so subtract 2 from both sides. Subtract and subtract. That cancels. Over here, guys, 2 up here, 2 down here are not like terms. 2 is not imaginary. The one down here doesn't have an I, doesn't have a radical. So you want to write it as a complex number. So a complex number is when you have a real number and an imaginary number together. Real number is first and then the imaginary. So this is the real one. So I'm going to have the negative 2 here. That's the real, plus or minus the imaginary number equals x. You can have the x on the other side if you want. You don't have to, but those are the two complex solutions. Remember, we have two of them. One is negative 2 plus 2i square root of 2, and the other one, negative 2 minus 2i square root of 2. Just keep in mind that a complex number is when you have a real number, for example this one doesn't have an I, combined with an imaginary number with an I. Alright guys, I'll see you guys later.